Hi, welcome back to my channel, and today we're gonna figure out how the Gemini or ChatGPT or Cloud AI do the deep research agent. So, if you are using the Google Gemini or ChatGPT, I bet you kind of feel familiar with the research or the deep research of the Gemini or ChatGPT. It takes a lot of time, but in straight you will have the better performance of the LM, right? So what's the a deep research agent? So I today we're gonna use a Astropic. Astropic is the mother company that create the Cloud AI. So today we're gonna use paper of the Anthropic to figure out how they build a multiple agent research system. And today we're gonna use LangChain and LangGraph. So cut to the chase, you can reference this paper later. If you look at this high level architecture of advanced research, you can see that when a user sends requests, there are a lot of multiple agents, and the list agent does have a tune search, a MCP tune, a memory, and is controlling the other sub-agent. And what this sub-agent do? Each sub-agent will do a specific task in that research. So, as you so let's say I have a research topic here, and I will ask the Gemini to do it for me. You will see that the Gemini will actually create a plan for the research, right? So this is the same as the list agent. It will create a plan for the research and divide those plan for the sub agent and make the sub agent run in parallel, right? To make the time consuming less, and yeah. So you know the idea of the what the lead agent does. And here you can see that in the Gemini they have a detail of a plan first. And yeah, and today, so now we're gonna go to and deep dive in how to apply this multiple agent. Yeah. So for easy for beginner, I will use the LangChain and LangGraph, but I will use the rebuild agent with a React agent. So you can reference this LangGraph website how to build a quick start React agent if you want to build it by your own, or you want to use this or modify it, right? And this is the how the React agent graph work. So this is the basic React agent with our React agent currently, and this is the React agent with structure output. We also will use this in our in this session. So yeah, a React agent you can think of it like it will have 3 steps, right? React, which is React with reasoning and action. So when the model receives a user message or a step, it will reasoning about that step. So like what's it to do next and what's need to do after that, right? And with will action, what action need to resolve. Yeah, but I think the Llama index implement the React agent better in its core concept than the LangGraph. So the LangGraph is just basically a LM using the tool. So yeah, and for the LM today we will use locally, and I will use the Quen 2.5. And I bet you all familiar with the Ollama, which is a service, a program that allow you to run the LM service under your local host, and choose whatever you needed. So let's dive in. So I have a LM with the mainstay for the list agent right here, and I will have a sub agent for the sub research agent right here. So this where I download the Quen 2.5, and so you see that I can choose differently model for the Tavily agent. This will lead into that you can choose the list agent is a law-based model, thinking model with a very lot like intelligence in it, and make it to control the multiple tasks. And in the sub agent, you just need like a small LM that's called SLM, by the way, and using that will save you a lot of time and a lot of money. So yeah, the design is spend you, and obviously if the main LM we see the answer LM, I can choose to for the temperature like 0.5 which leading to the case that is more relative, or I can configure like 0 like to make it more precise but reduce relative. Yeah, it's basically pay on you config, but it's not affect the sub LM, which the case that very useful. Now this is the easy way but less dynamic. For the more dynamic way and how I will instruct you in the other video. So now you just need to know that when the sub agent with this will have the output of the summary content of what is found, the URL of the website, and the title of the website. So I will have a search website tool here which I'm using the Tavily Search. You can check the Tavily Search website and get the API key for the searching. So while you Tavily Search, the Tavily Search will return the the structure output is more better, and they have like the built-in very useful and easy to use. And so that's why you Tavily Search. You can use the Google API search if you need, or other search, or other tool if you wish. Yeah, you could use the MCP servers for this also. And now the next part is the core researcher, which is how we call the sub agent in here. So how I do it, so I treat each of the researcher is a sub agent. So you can imagine like this is a reaction, this is a reaction, this is a reaction, and you treat it like a tool, right? So yeah, when you call the tool, it will actually activate another reaction with a different tool, with different system message for it. So here I will create a reaction which get the configurable passing. So if you're not familiar with the runnable config, which is a dictionary which you passing for the tool use for it. So yeah, so basically I will pass in here a system message that was the task of this researcher. Like you are a researcher agent, you are given a task requirement and you need to research the task and return the result. Your internet will be your source of knowledge. So yeah, and the human message here is the task requirement. So I treat it like, as you can see, each of this like a task requirement for it, right? So it divide for this case, maybe divide for 8 subagents to do a parallel research and summarize the content for the list agent here. This also similar in that case. For the task requirement, you will need to have the task requirement in here. Yeah, so I create a class called the research agent, and yeah, you will put a system prompt into the React agent with for the list agent. And here's the prompt that I use. Your agent list of the research team called Nhân Lab. Your task will be planning and assigning tasks different subtype research to a researcher. The best strategy is to break down the task into smaller subtasks and assistant. Yeah. So basically, here's all the prompt, and here is why we say this is the tool that you can use for the lead agent. And as you can see here, this is the tool the sub agent can use with the search web. And here's the config. This config variable will be passing the tool you with by this config tool with through the configurable. So this runnable type is a type dict, so it's usually have a duck like a method like the keywords remind you to it have a configurable. So yeah, basically that's the whole point. It's very simple, very easy, and you can see here is I have the run here, and the run will get the memory. We store the memory in it. So if you know that when the agent output, it will output all the memory it have. We see the ribbon here, but we only need to answer the user for the output, right? For the container here, we see the last message for the LLM answer. So let's run. I will use the quantable file latest which is the 7 billion parameter. So you can use the smaller model, but I prefer this 7 billion. Okay, let's go. Now we will run all. Sorry, my bad. Okay, we will run noise again, and as you see, there's a input with the for the user input. So I can say hi. Yeah, so I will pass this here into it, and I will answer. There's error in the config rule. I believe this is the case. I will solve this by if the LM doesn't have it, I will directly passing the LM sub. Yeah, that better. Okay, now run again. I believe we will need to run again. Sorry, I didn't push the rec here. My bad. Okay, no problem. We'll run it again. So let's say hi again. Yeah, so now we'll pass in this requirement, and actually it will, yeah, it's currently using the web search, calling the task. Yeah, actually I see here it's only called one researcher, which is not a like small enough, right? So maybe a different model, different event will need. So later we will use the ChatGPT to see the result and compare it. Okay, why it's running? Yeah, I believe it's running okay. So let's say that I know about this. Yeah, I believe it's okay, but it's not dividing the task, which I'm not happy with it. So I will assist again, and I will try to change to the OpenAI for this model right here. I will use the GPT 4.1. Okay, the passing the API key, we see I already have the OpenAI. So now I only change the main agent with the dividing task, where the sub agent I didn't do is any I haven't changed any at all. But we will copy the information, copy this answer and pass for the comparison, right? And now we will run again to see the result. Oh, sorry, I forgot to say it. Let's run it again. Okay, so let's pass anyway. So here's how I plan the breakdown assignment task for game globally. Yeah, that's more like it. And would you like to modify and add specific? I would say no and make it continue with the research. Okay, now as we call the sub research here, and I will actually check my RAM. Okay, it's running this submodel here. It's loading like half of my RAM and run nearly 100% for the CPU. And you can see that it's called 1, 2, 3, 4, 4 sub-agent, right? And it's searching something in here. It's maybe searching more on it. So we gonna need to wait because my machine is only configured for one loading, and we also know that the Ollama can only load one model. Of course, you can use this multiple model in run parallel config in Ollama, but yeah, I forgot to configure it. So maybe it will take longer. So let's wait. Okay, I believe the result is too many chapters down here. I will, yeah, this the whole answer very long, right? Very long. So I will copy it and paste in another, and again I will exit it and try to match all using OpenAI, which will load faster this time. So now again the same question. So I will no continue like before, and this will be faster because it's running as the ChatGPT OpenAI. Yeah, you can see it's like searching more like the old one, right? It's searching the old one like just searching for keywords. This time it's smaller and it's searching small. Yeah. So let's see how it's answer. Wow, it takes a lot of time. Yeah. Okay. Now it's happy answer here. I will copy paste it. So now it's comparison time. The most different is the length of the answer. The last one is like 2070 character. This less than 200 word character. This the least. So yeah, let's compare with Australia, China. So this answer is like not focused on the like it's not deep enough, I would say. But this too, I assume is more. But in here I saw it that it's also a slang the where like more information than this. Yeah, so basically it's done a research that this normal LM wouldn't do it, like cannot do it. But with multiple agents we can easily do it, and that's, I believe this is the end of the video. So there's some con in this approach, I would say. Like when you use the React agent, is you know that when the React agent is running the tune node, right? So when the tune node is also, as you can see here, for the tune node it also gets all the conversation in the chat history, which leading to not necessary because it's too long for it. And other is that it's not dynamic enough. If you want to configure something deeper inside, like for the UL, you will need that some cannot be accessed, or you want to configure something about the chat history, you would not do it with the normal React agent rebuild. You would need to build again a React agent by yourself. So that's the next video. We will talk about how to build the more dynamic research agent, but it would be harder, but hard means you will learn something more. So that's the end of today's video. Thank you and see you in the next video. Bye.